Good afternoon, everyone, and thanks for joining the session. We are super excited to share something that we've been working on. It's a bit of a game changer for us at Swisscom. So we will share how we are evolving GitOps by tapping into the power of Kubernetes Resource Model. Could you please hands up if anyone's from the telco domain other than our Swisscom colleagues in here? Okay. There's less people, I think. So just to level things up, I would like to paint a picture. So let's start with an analogy. Good. Okay. You didn't miss much. So let's imagine we are going on a cross-country road trip. On one hand, you have this old-school paper map. It's quite static. It's fixed. It's also unchanging, and it's quite overwhelming for the user to navigate their path from one end to the other. And this is how we are experiencing the traditional GitOps model when we start applying it on our 5G core. On the other hand, you have your phone. You can use your Apple Maps or Google Maps, and it's quite dynamic. It changes based on the external conditions, such as traffic conditions, the weather, and it's more focused, and also it's very simple to navigate. And this is what we are aiming towards, quite dynamic configuration in a way, and we want to introduce Kubernetes Resource Model to the GitOps way of working. And yeah, it's quite exciting. So let's look into how we tackle this. Now, before we jump in, I would like to introduce the team. We've got Alexander North, Joel Strudler, and lastly myself, Ashan Seneviratne. We are part of the mobile cloud-native orchestration team at Swisscom. And if you want to reach us out, we are also available on Slack, on the CNCF, Nefio, and NetDev channels. So a little bit about Swisscom. Swisscom is the #1 service provider, a telecommunications service provider in Switzerland. Not just that, it's also the most reliable network service provider in Switzerland. Now, we are going through a journey from telco to what we call a techco. And it's not just, we just want to stay on the most trending topics or the buzzwordy stuff, but it's also super compulsory for us to embrace the cloud-native principles to automate and simplify how we do things in our networks day to day. Now, the 5G core, it's a big part of the transformation. It's also a stepping stone for us, and we would like to start from there and then apply the learnings to the other parts of the networks and services moving forward in our journey. So, telco to techco, what does it mean for us? I would like to boil down into 3 principles. Cloud nativeness. We are all in on Kubernetes. We want to introduce reconciliations and Kubernetes patterns for our network and infrastructure to make them more resilient and also scalable. We would like to introduce simplicity. When we talk about networks, it gets quite complex and the configuration becomes too cumbersome to manage. So we want to break them down into bite-sized pieces so it's manageable, and also it gives us less headache when we start scaling them. The automation, this is a biggie. We would like to move from an imperative or old-school step-by-step workflow-driven model to a declarative intent-based model. Now, simply, this means we don't want to instruct the system on how to do everything, like all the instructions, but instead we want to instruct the framework should only need what to do as an intent, and it should figure it out how to do it in the best way possible. There's a nice talk that's been done by our CTO, Mark Dusner, at Connect conference a couple of years back. If you want to look into like a high-level overview, there's this QR code. You can watch this video as well. With that, I would like to hand over the stage to Alex. He will explain you what the 5G core is and what are the challenges that we face.
Yeah. Thanks, Ashan. So, what is a 5G core? Well, it's a network architecture that provides essential functionality for mobile communication. Here is what a cluster would look like. Each of these objects is a CNF, or a containerized network function. One of them could be, for example, a router or an authentication service. And these are deployed using Helm. Configuration is done both via Helm and other configuration interfaces, for example, netconf. We are dealing with a lot of pods and configuration parameters. So in our dev environments, we have around 2,000 pods and a total of 5,000 interdependent configuration parameters over these pods. So what does the config currently look like? Well, this is an extract of configuration. Let's try and zoom in a little bit. And we can start to see that there is a lot of places where we can start to extract key pieces of information, which could then be used for abstraction. We spent quite a lot of time going through our configuration and trying to find what we can use or what we can take out and abstract. And this is what we're calling our configuration philosophy. So we discovered we have lots of parameters, thousands of parameters. This is not user-friendly. We really need abstraction here to simplify working with these. There's a lot of redundant information. We are seeing a lot of repeated pieces of information, and abstraction allows us to centrally manage these. And finally, we have a limited configuration discovery. It is hard for us to use Kubernetes resources as input parameters for our configuration. This is not fully supported. Now, when we're talking about abstraction, we should also look at the source of truth. So how can we manage the source of truth with GitOps? Kubernetes does something similar to this when they're talking about PVs and PVCs. So in Kubernetes, there is a separation between the requests and what is provisioning them. The claim, the volume claim, represents the intent, and the volume itself fulfills them. The user manages only names, not the low-level details. Kubernetes is the part that manages these parts. And we have then a source of truth split between Kubernetes and Git. But this enables abstraction and reusability. Obviously, there's a lot of benefits of abstraction, especially when we're looking at configs like ours. So we can reduce toil, we simplify our tasks and the management of them. We're able to ensure consistency, so minimizing the chance of errors, for example, changing a value in 3 places instead of the required 4. We're able to streamline processes, so leading to time saving. And when we're managing configurations at a higher abstraction level, scalability becomes much more simple. So how have we started to approach our config abstraction? Our goal, again, is to dynamically fetch config data from the cluster and hydrate the config. So hydration is what we're calling this process of populating low-level details from a high-level intent. Here we have a diagram showing the flow. We start off with an input resource, we have some logic, and we have an output. The logic should be able to access resources on the Kubernetes cluster, whether they be managed by an external resource or external source through an operator, or whether they're just living on the cluster. A more concrete example of this will be shown by Yoel later on as we dive into the details. So this is what we want to do. What about requirements for doing this? We start by saying we want our input and output resources to be KRM-based. We want interdependent resources to be grouped and to live together. So if they're removed, then all of them should be removed, and vice versa. We want some flexibility in the output. We want to make sure that the output can be stored in various ways. Changes to the input should involve a change to the output. We would like to use some custom logic when we're doing this hydration, for example, string concatenation. And we want to be able to gradually migrate from our current static configuration to a dynamic approach. So you might ask, OK, we already have some tools, Helm, Customize, Argo, Flux. Why don't we use these? Well, during our process, we found that there is some limitations, such as limited dynamic assembly. It is not so simple to get information from the Kubernetes cluster to then involve in the templating process. Arbitrary code is also not something that's so simple to do. We cannot just write arbitrary functions and have them run. And not all resources follow the KRM. So KRM, what is it? It consists of 3 parts. The first part being API extensions. We have new functionality defined in the Kubernetes API. We can use custom resources to instantiate these extensions. And we have some business logic, which could be done through operators or templates. I'll now pass over to Joel to discuss the steps we've taken and what we've been able to research.
Thank you very much. So before I do that, we have an announcement to make. So we are internally at Swisscom, we are using Netbox as an IP address management tool, and for you can also use it for VLANs, pretty much assigning any network resource. So we just open sourced Netbox Operator, which is a tool that allows you to integrate Netbox into your Kubernetes resource model, basically. And we're also going to use this in the demo. So if you're interested, check it out. It's published on the Netbox community GitHub organization, and it's ready to be used, still in a very early stage, obviously. So going back to config abstraction, we've added a QR code as well to the Git repo that contains all the demo resources we're showing today. There will be a lot more in the repo to explore. I will only scratch the surface today, so please go into more detail in these resources in the Git repo. So we've seen the diagram before with how this hydration works. So this is a very concrete example now. We will start with an input resource, which just defines a parent prefix, which in this case is where we get an IP from. And the goal is to get dynamically an IP prefix from Netbox, from this Netbox system I've just explained, and then create a MetalLB IP pool for the load balancer. MetalLB is a load balancer for Kubernetes, very well established. So there's this config map. We're going to apply it to the Kube API, usually through GitOps. In this demo, I'm doing it manually. And then we will have some kind of hydration logic that reads this resource. We'll render a prefix claim. So that's similar to the PVC-PV relationship. That's how we implemented it in Netbox Operator. We will claim a prefix that comes from a certain parent prefix, and it should have a certain prefix length. That's all we tell the system. Then we apply it to the cluster. We will have our Netbox Operator reconciling this resource. So that's the integration that is done outside. And then at some point, the status will update on the prefix claim. And as soon as that's done, we can continue and render the final MetalLB config and apply it to the cluster. So that's a very simple example of this dynamic config hydration, which we aim to be using for our config management. So that's obviously just one parameter. We have 5,000, so it's a long way, but it's a first try on this. So let's have a look at 3 concrete examples or 3 technologies. I'm going to introduce 3 examples with and live demo. The first one is Ansible. The reason why we tried Ansible is that we already use it heavily in our 5G core automation, and it will allow us for gradual adoption from a more static approach, like the paper map approach, to a more dynamic, on the cluster, on runtime approach. So a few words about Ansible. It's an open source automation framework, very well established. You probably know it already. Its business logic is implemented using templates and playbooks. It doesn't manage state. So in this case, in the case of Kubernetes, we will rely on Kubernetes garbage collection using owner references. And there's no reconciliation. So in the end, Ansible is just a binary, a very big binary, but it's a binary. You don't actually have triggering or execution solved. So you need to solve that outside of Ansible with tools like Argo workflows or something. So when we look at the config or the hydration flow, we will have the input config map. It's a resource of type config map. We will sync it to the Kube API, and then we will need to manually trigger Ansible. As soon as this is done, it will fetch this config map, render the prefix claim, apply it to the cluster. Netbox will reconcile it, eventually update the prefix in the status field, and then we can render and apply the MetLB resource. So I'm going to now show this in action. The first thing is I'm going to show you the config map. Is it big enough for you guys? Bigger, please. OK. Like that. Yeah, that should work, right? OK. So we have this config map. It contains 2 parameters, parent prefix and prefix length. That's what it is. If I apply this to the cluster, not much happens. On the top, you will be able to see all the resources relevant for our automation. It just applies it to the cluster. Since Ansible doesn't run automatically, that's pretty much all that happens. Now, if I run the Ansible playbook, what will happen is it will create the prefix claim, and it will create the prefix itself, and eventually it will create the IP pool. So there's the IP pool, and you can see it's matching with the prefix we got dynamically. So it's a /24. That's what we asked for, right? Yes. So now that this is hydrated, let's test it by just creating a few random load balancer IPs, and you can see it's getting the IPs from this range. For cleaning up, since we're using owner reference, as mentioned, I can just delete this high-level resource, and everything else will be garbage collected, deleted by Kubernetes. So that was the very short Ansible example. Let's go have a look at one more technology, which is Kform. Kform stands for, it's inspired by Terraform, but it's built for Kubernetes resources. It's a fairly new project coming out from the Kubernetes community, led by Wim Hendricks. And yeah, go have a look. If you like it, please contribute, please give feedback. The business logic is contained within templates using CellGo. State management is done using Kform, similar to the Terraform state. But in this case, it's not stored on a file in your file system. It's stored in the Kubernetes cluster itself as a config map. And then the last part, reconciliation, similar to Ansible. It's also not covered because Kform, just like Ansible, is just a binary. You execute it. So if we look at the same architecture flow again, we would have the input config map. It's still a config map with the same parameters. In this case, with Kform, we don't apply it to the cluster. We just make sure that when we trigger Kform, that this file is available on the file system. So Kform will read that from the file system, create the prefix claim, same as in Ansible. Then it will apply this to the cluster, wait for it to be reconciled. As soon as it's reconciled, it will render the output IP address pool and apply it to the cluster. So to see that in action, there are plenty more commands to help you set up Kform. I already did that. What I need to do first is do a Kform init, which actually initializes the Kform inventory, like the state, so to say. Then we can have a look at the resource. It's pretty much the same resource as before, only that we now have annotations relevant to Kform, so that's how Kform works. It's pretty much using these annotations for managing things. So what we now need to do is that we need to execute Kform apply, which will then run the logic that we need for templating. So you can see again, it's creating the prefix claim. The prefix will implicitly be created by the netbox operator, and then eventually we should be able to see an IP address pool in the MetLB system. So this one matches now with this new prefix. So it's different prefix from before. And we can do the same test again using services of type load balancer, and we can see it's assigning these new IPs. The cleanup of this kform example is done using kform destroy. So this will read out the inventory, and based on this inventory, it will know which resources to remove. I'll prepare the next demo and switch back to the presentation. So that was kform and Ansible. The third technology is probably something more familiar. It's just a Kubernetes operator. We used Golang-based operators using KubeBuilder. You can use pretty much any language nowadays. There are plenty of libraries. We can write business logic in Go code, so we have maximum flexibility, but also maximum responsibility, I would say. We do have the Kubernetes state management, so Kubernetes garbage collection is built in, or is the supposed to use tool for state tracking, finalizers, and all of that. And in addition to the other, or what we didn't have with the other solutions is reconciliation. Since the Kubernetes operator will be running on the cluster, watch the Kube API, we will have an event-driven system and constant reconciliation. So the same example, in this case, the input resource will not be a config map anymore. It will be a typed custom resource with typed fields. So we can have some input validation in addition. We will apply this to the Kube API. And since the operator is watching this resource, it will immediately trigger the reconciliation. It will do the exact same things, wait for the prefix claim to be reconciled, create the output resource, the methodology IP pool, and then apply it to the cluster. So to present you this solution, the first thing I do is I build the operator and I run it. I run it in background in my shell, so you can see that when it's triggered, actually, it will not be very helpful to log, but at least we'll see that something happens, right? If we look at the custom resource we have here, it's a resource of kind configuration, so it's not a config map, it's a custom resource, and we will have the same parameters still. So since the operator now is running, the only thing I need to do is I apply this custom resource, and you can see it immediately reconciles the resource, and eventually you can see that the methodology IP pool was created. Let's have a look if it's matching with what we expect. And we can see it's 10.0.2.0, so that's the exact same prefix that we expected. And we can also prove the same thing again using load balancer IPs and see that they're coming from the correct range. The deletion in this case is similar to Ansible. I just delete the high-level input resource. You can see everything is gone quite immediately, and the reconcile loop is not even triggered. So this means Kubernetes takes care of it and not our operator. I will kill that now to clean up. And that concludes the demo part. So you've seen 3 different solutions: Ansible with Jinja, templates kform, and the Kubernetes operator. This rating, I won't go into details, but what I think is important to note is that there are certain advantages and disadvantages with each solution. We've also looked at KPT, Crossplane, Helm. There are plenty of tools available to do certain things, but what's important for us to note here is that, there's no mature Kubernetes native tool available for this config hydration. And that's probably the bottom line of this talk. So we think we were elaborating, but we still think the industry needs to go further into depth and further elaborate on or find proper solutions to this problem. And with that, I hand over to Ashan for...
Yep, thank you very much. Yeah, so we covered a lot on the ground level, so let's take a few steps back and zoom out a little bit. So a few key takeaways. So we found that it's very challenging to have dynamically add parameters to Kubernetes resources in GitOps environments. And as Joel mentioned, that there's a tooling gap. There's no mature tools out there for the config hydration to introduce with KRM approach. And the existing solutions that we have, there are shortcomings. They've got strengths, but not really applying or not really suitable for what we need to have on a scaled level. And lastly, it's not just telco specific. It's all the other industries are grappling on this, who are aiming to do this dynamic config hydration and assembly on the Kubernetes level. Yep. So next steps for us, we still want to have this future state. So in here you can see we would like to have a high-level intent, move away from this 1,000 size of configuration, and have this config assembly or the hydration done in the core by using multiple operators or a templating engine that we're going to hopefully find out at some point. And then apply the configuration to the 5G core. And we have outlined few clear steps to this. We would like to keep an eye on the advancements on kept or Kform or any other tools that's available in this Kubernetes management. And in parallel, we would also like to spend some time on implementing a Kubernetes operator for generic templating. Look into the management, multi-cluster management. Look into Project Nephio or KubeNet to see if we can leverage some of the components from projects like that. Implement safe rollouts with configuration versioning, and also build other safety nets needed so we have a smooth config rollouts. And lastly, it's not, as I mentioned, this is not telco specific, so we would like to collaborate with the vendors and as well as the community to find the best suitable solution for this. So we've also spent quite time on config abstraction, so we would like to share learnings and some suggestions. Yeah, so we would like to avoid checking in low-level configs in Git, so things like IP addresses, VLANs, and all the other nitty-gritty information that's not needed and that can be dynamically done by the surrounding tools and operators. Config abstraction introducing abstraction is nice, but be cautious. Don't introduce too many levels of abstraction, so only introduce abstraction where it will simplify your processes. Ignore tooling like Ansible or Jinja. Don't force them on where it's not belonging to do the Kubernetes native work. And yeah, as I mentioned, this is don't assume that these KRM challenges are unique to you. So associate with the community. And aim to simplify the configurations by focusing on essential controls. Reuse cloud-native tools like Flux, Argo CD. If you're implementing a Kubernetes operator, if you're introducing or designing KRM-based tool, make sure you keep an eye on the future so it applies on other use cases and also it's scalable. So we identified this tooling landscape is evolving quite rapidly, so keep an eye on your KRM practices and be agile so you can evolve your processes as well. And lastly, contribute to the ecosystem. We have done it, and we have seen it's quite rewarding to see that how the community benefits from the tools that we have open sourced so far. So with that, I would like to wrap up. There's a related talk that Joel and a few other colleagues from our team are doing on building and operating a highly reliable cloud-native DNS using open source tools this afternoon. And we also have a couple of talks referenced in here. These are the previous talks that we've done that has laid the groundwork to this talk. So please feel free to have a look into this. Yeah, so with that, I would like to close the session. Slides. And open the question round. So, by the way, you can scan the QR code, all the slides and all the demos. That's all stored in this GitHub repo. Yep.
And the slides, yeah.
And the slides as well. Yeah.
Mm-hmm. Thank you very much for this very interesting talk. before jumping into the questions, again, please give feedback, rate the talks, give us some feedback to help us improving. Very interesting talk. Actually, we had one question, still interesting. Can't you achieve the same hydration logic with customized in Terraform here? Why wouldn't that suffice in your use case?
Did you want to show something? Or?
Maybe we do have a slide on that explaining, so maybe we can.
Yeah, sure.
Yeah, so I think you could partially. So with for instance with Helm, you can fetch parameters dynamically from Kubernetes resources, but customized, I wouldn't know. So I think the thing we're really aiming for is dynamic assembly and not having GitOps to having Git to know everything and then apply this to the cluster. So I think we're really looking for a more dynamic approach, and we think that customize Helm or what other toolings were mentioned?
Terraform.
Terraform as well. I wouldn't know how you could dynamically fetch this in a scalable way from the live state
within the Kubernetes environment.
Within Kubernetes, yeah. Mm-hmm.
I would ask one question. So you were talking about a tool called Kform, from which I briefly discovered thanks to you. Seems like so the tool seems to be in his very early stages. Do you use it in a production yet, or?
No, not yet. It was released maybe 4 months ago or 3 months, so it's really bleeding edge at the moment. Yeah. Yeah.
So from all the tools that you have explored, which one are you nowadays using in production? And do you see some values into probably switching to Kform, for example, or another one in the next, I don't know, couple of months?
So at the moment, we have custom operators implemented. Mm-hmm. But the limitation that we've seen is for each use case, then you need to implement another operator. So there's quite a lot of operational overhead on us. So that's why we were looking for a generic way of assembling this config on the Kubernetes layer. And Kform is not that stable at the moment. It's still in beta release, I would say. So we are keeping a close eye on Kform, as well as some tools like Kept, for an example, that's used in Project Nephew.
Also for the requirements, we state that we don't want to go immediately from a static to a dynamic in one step. We want to have a gradual adoption. So we will, over time, we started off with looking at operators and implementing it, and then we still have also the static configs, not just completely moved over straight away to the dynamic.
Clear. We have one last question, which is, do you consider using KCP? KCP, I don't know who asked the question, if she can raise her hand just to give probably more.
KCP.
KCP, yeah.
Yeah. So yeah, we're also having a look at it. I mean, I currently don't see how the interaction between actual Kubernetes container workload and plane control plane things are gonna look like. And as well, so what's kind of risky from my point of view now is that it's not built into the upstream Golang binaries, so it's still custom, somehow forked code from the upstream Kubernetes. But I definitely think it solves some of the issues we're also facing. It doesn't solve the config hydration part, though. It will eventually enable us to have this highly scalable control plane with this workspaces concept and so on. Yeah.
Okay, then thank you very much for this very interesting talk. Can we give a big round of applause for our speakers, please?
Thank you very much.
Thank you.